Hi. Welcome. Before we get started, so today's going to be about homework 2. I got a lot of stuff to talk to you about with homework 2, but before we get started, any questions on homework 1, which is due tonight, this evening? Any last minute questions on homework 1? Hopefully most of you are finished or close to finished. Yeah?
So is it just based on the tests, or do we also need to look out for edge cases?
Based on the tests, yes. I will say it 100 more times if I have to. Said it 100 already. Based on the tests. That's why we're doing it. Any more questions? All right, let's talk about homework 2. So homework 2 is based on the material we've been talking about over the last couple of weeks. So that means we're going to do relational. What the heck happened down there, huh? That's weird. That means we're going to, what the heck? Where did that come from? Sorry. That means we're going to do relational operations on this homework assignment. So the relational operations that you are responsible for are the ones that we talked about in class. Should not be a surprise that I'm asking you to do these operations. We've talked about all of them. We've gone through examples, I believe, of just about all of them. So select, project, rename, join, and aggregations. Now, I have included some simplifications of some of these just to make life a little bit easier for you, hopefully. For example, joins. There's a join condition that we talked about. We've seen several joins by now, right? So part of the join is the condition, the part that comes after that keyword on, right? To keep things simple, you can assume that this will always be an equality. It's not going to, technically you could use greater than, less than, not equal to here if you want to. But just to keep things simple, we're going to assume that joins are always going to be the equality operator for the columns that you are checking against. Aggregations have a lot of simplification, actually. They're going to be simplified quite a bit. So what that means is, so aggregates, we actually have two cases that we need to worry about, with a group by and without a group by, right? So if I ask you to aggregate without a group by, that means there's going to be one column. That's it. There will only be one column of data. And so all you have to do is aggregate it. If I ask you to aggregate with a group by, there will be two columns. There will be two columns. The first column is what you should use for the groups. And then the second column is what you should be aggregating, summing up, or averaging, or finding the max, or whatever the case may be. Excuse me. Other than that, I don't think there are any real surprises in what I'm asking you to do. We can actually take a look at the code, starter code that I gave to you, but it's not going to be there's not going to be a whole lot of stuff to look at. I gave you a lot less starter code this time. There wasn't a need to provide you with a whole bunch of stuff. But a couple things that I do want to point your attention to. Notice that the return type for all of these operations is a relation, right? Perform a relational operation, I get a relation back out so that I can take that relation and feed it into the next operation. That's how we perform our queries, by chaining these operations together. Let me give you a big fat hint right now about renaming things, about renaming column names. Remember that the rename operation is a temporary renaming. I am not permanently renaming the columns in the table. The columns in the table should have the same names after this operation ends. I'm only renaming the column names within this relation, not a permanent renaming. I say that because I see people make this mistake a lot. I'm going to see people make this mistake again, even though I'm talking about it right now. But I'm going to bring your attention to it because it is a common thing that I see. Be very careful with this. It seems very easy, I know. It's actually one of the most common point deductions that I take on this assignment, are people not implementing this method properly. Projections are pretty straightforward. All joins will be joined with equality, and then the columns that we're going to use to perform the join are given to you as integers. So that's the column number. So the first number is the column number from the left side. The second number is the column number from the right side relation. And we're only doing inner joins. I suppose that should be made very clear as well. You don't have to implement outer joins as part of this assignment. Only inner joins. Aggregations, there's actually a second object called an aggregator that I expect you to use to perform this operation, which is also very simple. It's got basically two methods that you need to worry about. The merge method. So the way that an aggregator works on a typical database is I feed it one tuple at a time, right? As I feed you tuples, you are going to update the aggregate. So if I'm taking the sum, as I feed you tuples, you'll keep updating that sum, updating that sum, updating that sum. Or if I do an average, right? Same idea. Feed you a tuple, update the average. And then once you're done, or actually at any point in time, you can call getResults to get whatever that current value of the aggregate is. So that should be a very simple one-liner, hopefully, getResults. If you do it correctly, it should be a very simple one-liner. I do see people doing more work in getResults than I typically would like, but if you have a good design, it should be a very short method. That's going to do it for the relations part of the assignment. Are there any questions about that before we look at the second part? So the second part has to do with actual queries, has to do with processing queries that are coming in. So it's not enough to perform the relational operations. I want to give you a SQL query. I want to give you a select statement and have you process that select statement. So that's part 2 of the assignment. I'm going to give you a SQL query and ask you to parse it, basically. Well, not really, actually. I'll show you an example in a little bit. I'm going to ask you to process that query and determine what relational operations are necessary to retrieve the results of that query. You're going to be executing that query, basically, based on those relational operations that are necessary. You're going to have to recall our discussion on the order of operations, right? We don't read queries left to right, top to bottom, or at least that's not how they're typically executed, right? So think about what comes first. You're going to have to do that first in your code. What comes after that? What comes after that? So to help you with this, parsing is how do I want to say this? It's kind of tedious. And this really isn't the class to teach parsing in detail. I'm not interested in that. I'm not interested basically in having you guys construct parse trees. That's outside the scope of this class. So I've provided you with a library in the repository. It's called JSQL Parser. And what it does is it's a Java library that takes in a SQL query and creates a parse tree for you. It creates a parse tree for you. So you don't have to create the parse tree. You're basically starting with the parse tree, but you do have to go through the parse tree and find the appropriate operations, or find the appropriate nodes in the parse tree, and then call the appropriate relational operations to perform the query. In class, we talked about how we actually construct another kind of tree called a query tree. I'm actually stopping just short of asking you to construct a query tree. You do not have to create a query tree in the sense that I'm not expecting you to create a second set of nodes that are connected together. That is not part of the assignment. But you're almost doing that as you're processing this parse tree. This is the part of the assignment that typically gives people the most trouble. So I do want to go through this code a little bit and show you some things that I've done so that as you're working on it, you can kind of understand it. I'll give you some hints about this one as well. The query class is where this all happens. And I got you a head start on this one. I gave you a little bit of a head start on this one. It takes in a statement, or a string, right? That's literally just the query. Select from, where, group by, that whole deal. It gets passed into the parser, which then is going to create a parse tree. And then this pulls out the query. So you'll notice that I'm actually pulling out a select object and a plain select object. So you're going to start here with this plain select object. That's your starting point. What's the first operation, or what's the first part of the query we're going to process? From. So you need to figure out how to get the from information out of that plain select object. But you've got some tools at your disposal. Specifically, if you come down here, I've posted the API for the parser. So you can view the API for this parser. There are a lot of different node types. I'm not going to sit up here and pretend that this is a small amount of stuff. It's actually a large amount of stuff. Thankfully, you don't need to go through all of this stuff. You just need to find the stuff that's relevant to you. So here's the part for plain select. I want to get information out of this. Oh, hey, look, there's a method called getFromItem. So if the from clause is the first thing that I want to process, that's probably a good method to start with, right? And then what might you do after that? Well, let's go take a peek at what from items can provide to me, right? They can probably give me some information about the tables that I'm going to need in this from this query, so that I can look those up. And so what I've done, I've even gone a step farther, because I understand that there is a lot of information in this API, and I don't want you to have to sit there and sift through all of it. On the write-up, to hopefully make your lives a little bit easier, down here towards the bottom when we get to the queries, I actually list, where is it? Here we go. I actually list the types of objects from the parse tree that you will need to perform this part of the assignment. I believe that you can complete this part of the assignment using that set of objects. So look them up, see what methods they provide, see what they can do for you, and then use those methods to grab the important information out of the query and call the appropriate relational operations to execute that query. I've also provided you with a little bit more help. On Tuesday, we talked about the visitor pattern. I've given you 2 visitor classes that you can use. You do not have to write your own visitors for this assignment. I'm not asking you to do that. But I have given you 2 visitor classes, and I do expect you to use them. I've given you a column visitor, and I've given you a where expression visitor. I've actually given you another visitor class that you shouldn't have to touch. So 3 visitors in total. But you do have to mess with the column visitor and the where expression visitor. And we can take a look at these real quick just to see how they work. A little review of what we talked about in Tuesday's class. So the way a visitor works is it's looking for specific node types, right? I'm looking for specific node types in the tree. So I'm going to construct an instance of this class and then pass it to the tree. It's going to traverse the tree then, and if it finds a node type that it cares about, so what are the node types that it cares about? Equals to, greater than equals. Oh, those are relational operations, right? Those are typical Boolean operations. It's going to basically just record that it's seen that, so that you can appropriately process the where clause of the query, because you're going to need that information as you process the where clause. And then down here at the bottom, there are some methods that say, get me the left side of this expression, get me the right side of this expression, and get me the operator. Is it greater than, less than, equals to, etc. You're going to need to construct the visitor, pass it to the tree. When the visitor is done traversing the tree, you'll call these methods and stick them into your relational operations to perform the operation. Yes?
So the tree that we get that we're currently generating right now actually can accept this as a parameter?
It can, yeah, and I put a little code snippet on the write-up, I believe. Didn't I? Did I not? I did. I put a little code snippet. This uses the column visitor, not the where expression visitor, but still. Column visitor, so this is just constructing a new instance. I say node, so that's a node from the tree, dot accept column visitor. Now, I've been a little bit misleading, I suppose, in my discussion. I've been saying we're going to traverse the whole tree. That's actually not necessary. It's possible to only traverse a subtree, right? The part of the tree that actually has the information that we care about. And so you really should consider doing it that way. Call the where expression visitor on the where clause part. Don't call it on the whole query. Call it on the where clause part. If I'm trying to get column names out, right? Call it on the select items. That's what's going to be what holds our column names. Don't call it on the entire query. It's not necessary. Call it on the subtree that matters to that particular piece. So you can use this code. Please use it. I mean, it won't work as written. Node needs to be some node from the tree, right? So you need to figure out how to get that node out of the tree before you can use this code. But otherwise, this code should work just fine. You can use it to pull the columns out. You can use it to detect whether or not there are aggregates involved. So it will tell you if there's a min, a max, an average, right, involved in the query. And you can also use it to help you process the where clause. What kind of where clause is this? What are the values on the left and right hand side of the where clause? Any other questions? Any other questions? This is kind of a lot. Hopefully you saw this from the first assignment, but I'll say it anyway, just so we're entirely clear. This is not a short assignment. You have 2 weeks to do it, but don't wait. Please, please, please don't wait. The second part trips people up every time. Please do not wait. Start on this now. Start on it, as soon as you possibly can, so that if you get stuck, you have time to come in and get some help, and you're not struggling at the last minute to get this finished. Please, please, please get started. And along those lines, too, I should note that in order to complete this assignment, you do need a functioning version of Homework 1. So if you took an extension on Homework 1 or you didn't get Homework 1 finished for whatever reason, it's incomplete, you do need a working version of Homework 1 in order to complete this assignment. Specifically, the catalog class really matters a lot to this assignment. The heap page and heap file are less relevant. They're not as crucial. But the catalogs and the tuples are going to be used a lot on this assignment. So having a working catalog, having a working tuple class is going to be pretty crucial. If you don't get it done for whatever reason, I would really like for you to get that finished first. If you're like way behind, if you like totally tanked the first homework assignment for whatever reason, come talk to me. We can have a discussion and we can work something out so that you are able to work on this particular homework assignment. But I am not going to provide a solution to Homework 1. There are lots of reasons why I can't do that. A lot of people took extensions, so they're still working on the homework assignment. I can't publish a solution to Homework 1. You need to use your existing version of Homework 1 to start on this assignment. If you want to come talk to me about problems in your assignment, I can certainly go through stuff in office hours and help you fix things as well. So come talk to me if you need help getting Homework 1 up to speed before you start on this assignment. Any questions so far? Any questions? Let's see, what else is on my to-do list to talk about today? I believe I covered, so, I mean, obviously read the write-up closely. I haven't gone over every single possible thing that's on here, so take a close look at the write-up. Oh yeah, so I had this question before class. It's a good question. If you worked with a partner on the first assignment and you're not friends anymore for whatever reason, I don't know why that would happen, but it happens. You don't want to work with that person anymore. That's fine. I have no problem with that. That's between you and that other person, so figure it out. If you want to work with somebody else, that's fine. I don't have a problem with that. Make a new copy of the repository, though. Just fork it again. Put both of your last names on it. It's totally fine. You can use whichever implementation for homework 1 that you want to, right? I'm not going to come after you for academic dishonesty on homework 2 for stuff that happened in homework 1. Just make sure you make a new copy for your new group, and then just let your old repo rot for, you know, however long it needs to before I get it graded. So go ahead and do that if you need to. If you're going to continue to use the same repo for homework 2 that you use for homework 1, if you work by yourself, you're going to continue to work by yourself, or if you have a partner who you still are on speaking terms with, then you just need to do a sync. So you can do a sync by going to Bitbucket, and then over here on the right-hand side, you won't see it because this is my repository, so I can't do a sync. But you, if you go to your repository, you look on the right-hand side, there should be a big button that says sync. And it should pull down all, the code's already up. You can start on homework 2 right now if you want to. The code's already there, so go sync it if you want to. If you haven't finished homework 1 yet, I might suggest that you hold off on syncing until you get homework 1 committed. So commit homework 1, push it tonight, then grab the homework 2 stuff. That would be my recommendation to you, just so there's no confusion, just so there's no possibility of breaking stuff. But if you got homework 1 finished, you've submitted it, you're happy with it, you can go ahead and grab the homework 2 files and get started on it whenever you want. Or honestly, just make a new copy if that's what you want to do. Either way. Any more questions? I've got more stuff to talk to you about, but any questions right now? Any questions? All right. So we talked about this with homework 1, but we kind of ran out of time a little bit. We have a lot of time today. I want to talk to you about testing for this particular homework assignment. You're actually required to write unit tests for this assignment. I'm hoping we might have a little bit of time for you to do that today in class. I would love to do that today in class. Before we get there, though, I want to just have a little chat with you about what these things actually are, what it means to write good tests, how to write good tests. Some people submitted the tests for homework 1, and I got some pretty good ones. I got some not pretty good ones as well, and that's okay. I expected it. You know, I expected it. We didn't have a lot of time to talk about it. I appreciate you taking the effort to do that, and you'll get the 5 bonus points whether your tests were, you know, stellar or so-so. You'll still get the bonus points for that one. It's required this time. It's not 5 bonus points. It's 5 points on your assignment. So you have to submit. How many tests did I say? I honestly forget. Did I say 2 or 3? 2? 2 unit tests. So it's not a lot. I need those by Monday at noon. You could have them done before you walk out here today, probably, if you really wanted to. It's not a ton of work, but I need them by Monday at noon. What I'm going to do on Monday, I'm going to come in. I'm going to look at the tests that have been submitted. I'm going to grab the best ones, put them all together in a single file, just like I did for homework 1, and I'm going to give it back to you to use as you work on the assignment. And then I'm going to use those tests to grade the thing as well, just like I'm going to do for homework 1. That's going to be the process for all of the assignments in this class. But let's talk about what a good unit test is and talk about testing in general for a moment so that you know what you're getting into. There's actually lots of different kinds of tests, which it's a little unfortunate that the generic term for testing is called unit tests these days, but unit test actually means something. People use the term unit tests to mean all of these things, all of these different kinds of tests that take place, which, for day-to-day conversation is fine, but it's a little misleading. Unit testing actually has a specific meaning, and integration tests are different than unit tests, and system tests are different than what unit tests are. So I want to talk to you about what these different kinds of tests are. Only some of these tests are relevant to us, at least right now. Some of them might become more relevant to us later. But for right now, only some of these tests are relevant. Let's start with unit tests. Unit tests are used early in the process. Notice I'm asking you to write tests before you even start the assignment. Before you write any code to do relational operations or query processing or anything like that, I'm asking you to write unit tests. This is called test-driven design. I'm going to write some tests that explain how I think these things should work before I even code them up, so that as I am working on the actual implementation, I've got some kind of a marker that says, yes, I'm on the right track. Things are working the way that I expect, or, uh-oh, I screwed up somewhere along the way. I'm not actually hitting the goals that I set for myself. They're goals, right? Unit tests are goals that I'm trying to hit with my code. They're meant to test very, 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 very small amounts of code. Typically one method. That's it. Period. End of story. One method. So that actually makes our lives easier for this assignment in particular. This assignment, actually, I would say, is a much easier assignment to unit test than the last one was. The last one had a lot of parts that interacted with each other, and it just made it a little bit difficult to get in there and focus on one particular method of that assignment. Just took a little bit, it was a little bit difficult. This assignment, though, is much easier to approach a single method. So especially if I look at the relation class, excuse me, what do I have to do to use this relation class? I have to create a relation, which is really just an array list of tuples and a tuple description. And then I have to call these methods. And I can call this method by itself. I don't have to worry about it messing with any of the other methods, right? It's very easy for me to keep this method isolated from the other ones. So this code's actually a lot more unit testable than homework 1 was, which I think will make your lives easier when you're writing these tests. So pick a method and then figure out how to test it. For this particular setup, that probably means constructing a list of tuples, constructing a relation, and then calling one, or maybe two relations, if you're going to do a join, for example, and then calling one of these methods, and then checking the results. Yes?
One of the issues I had when I was writing unit tests for homework 1 is that I kept asking myself, should I, like when I'm doing the setup portion of the test, should I do something that I know is concrete, that I know, okay, I know this is the exact answer I'm supposed to get, or should I put in something that throws data in there at random?
Yeah.
And it would seem like, well, the latter would be more valuable in the grand scheme of things than the former, but at the same time, I don't know if the first one was acceptable, because sometimes I found myself writing a long page just to get the random stuff.
No, it's a good question. It's a very good question. I would say, actually, if we're talking about unit tests specifically, that testing something that you know the answer to is the right way to do it. Actually, I'm going to use simple, concrete values. I'm going to be able to figure out the answer to this unit test, or the expected result of this unit test, pretty simply. I can work it out on a sheet of paper if I have to, right? I can do the math. I can figure out what the results should be and explicitly list those results as the expected output of the test. That's what a unit test should be. It should be very simple, very narrowly focused. The second thing that you described, where I'm going to try and generate, a million random values and crunch them through this thing, that's actually a different kind of test called a smoke screen. As a smoke screen testing. You can think of that as sort of a beefier version of a unit test, I suppose. But a classic unit test is I have one situation, I know how that situation is supposed to work, I'm going to write a test to make that situation happen and check the result. And I'll show you some examples. I gave you a few starter tests as well. I'll show you some examples in just a second to see what's going on. So that is a unit test. Should be narrow focused, as simple as you possibly can, right? Focuses on one method and one method only. Now, that's all well and good, and unit tests are great, especially early on in the process. But as you start having more and more pieces, it's important to test how those pieces interact with each other. So the next step up in testing is called an integration test. And this is really testing how two modules, or it could even be two methods, interact with one another. Are they communicating what needs to be communicated? Are they in sync with one another? Do these modules actually work together? So here, again, we're going to try to keep it as simple as possible. The number of components is more than one, but it should be kept as low as possible. Ideally, the number of integrations, the number of things interacting should be 2. I might have 2 methods that I'm going to call and interact with each other. Or I might have 2 classes that I construct that interact with each other. And that's it. Now, maybe 3 would be okay if you have those more complex interactions taking place for an integration test. But really, we want to keep it as simple as possible. Again, we don't want to write these massive complex tests. Tests are code. Unit test code can fail just like any other piece of code that you can write can fail. So we want to keep it as simple as possible. The last thing we want is to have our tests causing errors that we have to figure out how to fix. And if we keep them very simple, we're going to reduce that. And so actually on homework 1, a lot of the tests that I gave you, a lot of tests that I received from you were actually integration tests. And I think that's okay too. If you want to write some integration tests and submit those as your unit tests, I'm okay with that. That's pretty much as far as I would want you to go though. Unit tests, very simple. I know one test case, test one method, that's it. Or maybe an integration test where I pick 2 methods in the same test, right? Again, keep it very simple. Pick a known situation where you know the outcome, right? And then code it up in a very simple test. These are the kinds of tests that you worked with for homework 1 and homework 2. And I'm asking you to work with for homework 2. That's not the only kind of testing though. So later on in the semester we might get to, first, here we go. I love this example. 2 unit tests. The door handles work. That's the unit test part, but they don't work well together because they block each other. This is why testing is important. The 2 unit tests pass, the integration test would fail if they had actually done it. This is not what we want to happen to our code, right? So integration testing is important. And so we're going to take that step up for the next round of testing. I am not asking you to do this. We are not going to do this now. We might do this closer towards the end of the semester. But we're not going to do this now. System testing is where we bring it all in, right? I'm testing the whole thing from start to finish. As many modules as that is, as many components as that is, I'm going to run the whole thing as one big unit and test it. So as you can imagine, these tests start to get a little bit more complex, right? There's a lot more parts. There's a lot more pieces that have to talk to each other, that have to communicate with each other. This usually happens later on in the development cycle. We don't even have a feature-full database yet. We're not going to have one until later on, and after we do a few more homework assignments. So there's no sense doing system testing at this point. And then the last kind of testing, which is actually one that people are very familiar with, is acceptance testing. Let your users try it out. Does it work the way that they expect? And are users using it the way that you expect? Is also an important question. This is also, so if anybody has ever participated in beta testing, that's what this is. Beta testing is acceptance testing. I'm going to release this program to a small group of people, let them actually try it out, see what kinds of things they run into. So as you are probably already aware of, beta testing and the like is like the next to last step before just putting it out there for everyone in the world to use, right? Making it public, making it available. We're not going to do this in this class. It's not relevant to what we're doing. We may do some system testing. What I'm interested in is the first two. I want unit tests and I want integration tests. Ideally, for you guys, I would want unit tests because we're still very early in the design process of this homework assignment, right? If you can write a good unit test, that means that you understand what that method is supposed to be doing. And I would argue that you should understand what a method is supposed to do before you start trying to write it. I don't see that happening all the time, right? But that's how it should be. You should understand how a method is supposed to work before you start writing it. Unit tests force you to do that. That's why I'm asking you to write some unit tests for me. And so we can take a look at the tests that I provided for this particular homework assignment. I gave you some for both queries and relational operations. So if I look at the relational operation test, you'll notice I'm loading up test files again, just like it was last time. Now, let me be perfectly clear about something. I'm getting a little off track here, but I'm loading up heap files, right? I'm loading up heap files that have tuples in them already. You actually don't even need to do that to test the relation class. You could make an array list, you could make some tuples, put them in that array list, and then pass them to the relation. You don't even need to worry about loading up a heap file, pulling tuples out of a heap file. It's not necessary. So if the heap file stuff is like, not your cup of tea, don't want to worry about it right now, or you're just tired of looking at it after working on homework 1 for the last few weeks, don't worry about it for these tests. Just make an array list of tuples, construct a relation that way, and write your test based off of that. That's perfectly fine. It's perfectly okay. These tests, however, do use actual heap files. And so you can see test select. What do? I grab all of the tuples from one of my heap files, and then I run a select operation on it. Does column 0 equal 530? Which SQL clause does a select operation match up with? The select relational operation matches up with which clause from a query? The where clause. The where clause. This is running a where clause. I've got a whole bunch of tuples. I want to figure out which tuples have the number 530 in column number 0. So go through every relation, right? Or every tuple in this relation. Find the ones that have 530 in column 0. They are the ones we're going to keep. The other ones we're going to throw away. So I should be able to see 5 tuples in my result. I can take a moment actually to show you this heap file too, although the text is so darn small and I still don't know how to make it bigger. This heap file, actually I see the first byte here is FF. What does that mean? FF. Very first byte is FF. What does that mean? Yeah.
The first 8 slots are occupied.
First 8 slots are occupied. There are 8 tuples. 8 tuples already in this heap file. 8 tuples. And what I'm saying, or what this test is telling us, is that of those 8 tuples, 5 of them have the number 530 in column number 0. So 530 in hexadecimal, I'm not sure I even know what it is, but it's probably this, because I see it showing up a lot. 2 times 256 would get us close, right? And then 12 more on top of that. Or 2 times 255 would be 510. No, it would be 2 times 256 would be 512, and then, oh, that's a hexadecimal 12, though. So that's actually 18. On top of that would get us 530. So this is 530. Again, I know that text is way too tiny, but it's there. It shows up 5 times. Here's another one over here. There's 5 tuples that have that number in this particular heap file. And so if I write a query to find them, or if I run a select operation to find them, I should find those 5 tuples, right? That's the idea. And so I've got similar tests for the other ones. Test project. Which projection matches up with which part of the SQL query? Select. It matches up with select. All right, so how does project work? Project says, I'm going to give you a list of column numbers, and those are the column numbers that I want to keep. This particular file has 2 columns, column 0 and column 1. I have given you a list with the number 1 in it, which means I want to keep column 1 and throw out column 0. I should get a relation that has 1 column in it, which is column 1 from the original relation. And so it runs some tests to check, is the name of the column the name of that second column, right? And so on and so on. So these are actually unit tests. These tests here are proper unit tests. They test one method. They test a known set of known values. I know what these values are. I know what to expect after I run these operations on those known values, and I can check for them directly. These are unit tests. Now the query tests, look at that. I'm giving you SQL. That's a SQL query, right? I'm giving you SQL, and then I'm expecting to get certain results back out. These are integration tests because the query has to interact with that relation class in order to do its job, in order to satisfy these tests. So it's 2 modules interacting with each other, the query class and the relation class. These are integration tests. It would be very difficult to do anything but integration tests for this because relations are such an important part of processing these queries. And so it's literally running the query. Some of these are, some of these are more complicated than others. Like I'm sure there's some joins down here. There's an aggregate. I'm sure there's some joins down here eventually. Oh no, actually there's not. Well, there you go. That is a very, oh no, there's one. I just skipped past it. You couldn't see it. There it is. There's a join. Right? So we're testing queries. And think about that for a second. What week is it? Is it like the 5th week of class? And we have already gotten to the point where you're going to have a database that you wrote, mostly from scratch, that can process SQL queries and provide the results. That's pretty awesome. That is pretty awesome. We're going to spend the rest of the semester adding performance improvements to that database. That's the plan for the rest of the semester. But in 5 weeks or 6 weeks, we've already got code that can process SQL queries. That's really cool, I think. Anyway, so these are more integration tests, but you'll notice that they're still simple. They look very simple, right? Come up with a query, construct the classes that I need, to execute it, check the results. Check the results. Now, these query classes, these queries, they do need heap files. I can test the relations without using heap files. I can just create an array list of tuples if I want to. That's not true for these kinds of tests. For these kinds of tests, you have to use the heap files because when I say from A here, what happens? What happens when I say from A? What is the code going to do when it sees that? Or what should it do when it sees that? Yeah. It's going to go to the Yes, exactly right. It's going to go to the catalog that you wrote in homework 1. It's going to say, give me the heap file for table A. And the catalog is going to say, here you go, hopefully, right? Hopefully it's going to say, here you go. And then you'll be able to grab the tuples out of that and perform the relational operations. So in this particular set of tests, you're limited to what tables you have available. You've got table A, which is that one we just looked at that has 8 tuples in it. And you've got the table that we had from last homework assignment, which is called test, that has exactly one tuple in it. Just one tuple. So we're a little bit more limited in terms of what we can do from here. You, of course, can make up additional heap files if you feel so inclined. It's a little bit challenging, but it's possible. Certainly possible to make new heap files and include them as part of these tests if you feel like you're limited by what you see here. So ideally what I would like to see you do is write one of each. One test from the relation class and one test for the query class. So one unit test and one integration test. That's what I'd like to see. I stopped short of requiring you to do that. So if you really just want to make 2 unit tests for the relation class, all right, I'll give you the 5 points. But I'd really like to see you try both. Yes?
I was just realizing it might be helpful for when I'm writing the query to actually know what's already in
Yeah, know the contents. I agree with you entirely. I could put it up here on the board, but that's not useful long term. So what I might do, and please remind me on Piazza if I don't, is post that on Piazza somewhere. I can actually post the contents of both of those tables. They're very short. It's only 9 tuples total. So I can absolutely post the contents of those for writing those queries. Are there any questions about what I'm asking you to do with these unit tests or anything like that? Any questions at all that I can answer? Hopefully it's clear. This is actually a much better assignment to get started on writing unit tests than the first one. The first one was a little tricky to test. And that's actually, without going too far off on another tangent, that's actually another important thing to consider is writing code that's easily testable. That's actually a good thing to do, right? I want to be able to test my code. I want to be able to verify that my code works. It's possible to write code that is not easy to test. And homework 1 was kind of borderline in that regard, in terms of its in terms of easiness to test. Homework 2 is much better, much easier to write tests for, in my opinion. So I look forward to see what you guys come up with. Again, those are due to me by Monday at noon. All you have to do is, I made actually another file for you, your homework 2 tests, and it loads up the heap files for you if you want to use them, right? So all you have to do is write 2 tests down here. That's all you need to do by noon on Monday is write 2 tests. Should not take you more than 15-20 minutes. In fact, I've got a little bit more I want to talk to you about, but you could even, like I said, have them written by the end of the day today if you want to. All right. I do have a couple more things, though, before we get there to talk about. Hello? Oh. Some tips for actually writing the unit tests. I've already sort of talked about most of these, but just to make it very explicit, make it very clear, we're going to use assertions to perform the checks. So I don't want to see if statements. If something equals something, right? You did it. No, that's not how it works. We're going to use assertions. You'll notice, you probably already saw this on the last homework assignment, but for these tests that I was just talking to you about, right? I have, actually this isn't correct. I should change this on the repository. That should be assert true. Ooh, I'm glad I noticed that. I need to update the repo. Sorry about that. Oh, I got that one right. I don't know why those were wrong. One more up top. Yeah, that's my bad. I'll update that like right now, actually, before it gets out of hand. You should use assert true. And actually, I should have probably even gone a step farther and provided an error message here, right? I didn't do that. That's me being a bad unit tester. Write an error message. Should be, right? Should be 5 tuples after select operation. Specify an error message. This message will only be seen if the test fails. So specify what you want people to see if your test doesn't work. Tell them what should have happened so that they can try to figure out what went wrong. I'll add some quick error messages on these and update these in the repo as well, so you have those available to you. Yes? I don't believe so. Should it? Oh, yep, you're right. It should be the first parameter. My bad. Get that swapped around. There we go. Yes.
We usually use assert equal statements rather than assert true, because then we can see like what was expected and what we actually got.
It all depends on what's available in the unit test library. We're using JUnit, which does recognize assert equals. I mean, there's multiple different kinds of assertions available. You don't have to use assert true. You can actually use any of the valid assertions that are available, which you can find if you look up the JUnit API. Should provide you with a list of assertions. Assert array equals, assert null, assert true, assert not null, assert false. Those are all acceptable assertions for you to make in your test. Yes, absolutely. And then some other tips. So these annotations are important. Anytime you see in Java an @ sign,